Okay, this is testing to make sure that I know how to use the software. UV radiation, lab purpose, baseline data. Okay, this is our yeast project lab report measuring the effects of UV radiation on yeast growth. And then the second part we measured what effect protectants such as SPF 30 has on yeast growth after exposure to UV radiation. UV radiation is known to damage skin cells and can lead to skin cancers. Many people use protection such as sunscreen or protective clothing in order to block UV exposure to their skin cells. In this lab, we were looking to see what effect UV radiation has on yeast colony development through exposure for 5 seconds, 10 seconds, 15 seconds, 20 seconds, and 30 seconds with a control of 0 seconds. This is part 1, data with no direct exposure and no protectant. We believe that if cells are exposed to UV radiation, then the number of surviving yeast colonies will decrease. So we performed our experiment, and as you can see, there might be an error in our data due to the fact that from 0 seconds of exposure to 10 seconds of exposure, the number of colonies has increased. However, ultimately, from 15 to 30 seconds, the number didn't decrease, so that could have been an error in how we labeled our plates, or there could have also been an error in how we did our dilution. As I said, we believe that our first part is flawed. However, overall, the data does support our hypothesis. Part 2, we exposed the yeast cells with a protectant using SPF 30. We believe that if the yeast is protected from direct UV exposure, then the rate of survival over time should be higher. We repeated the dilution onto the same type of agar plates, and we used a plastic wrap with sunscreen sprayed on it when we exposed it to UV radiation. Here we can see the data. Again, the data seems to be possibly inconclusive due to the fact that from 10 seconds to 20 seconds there was an increase in yeast colonies, and from 25 to 30 seconds there was a large jump in the number of yeast colonies, and we did not have a 0-second control plate for this one. So due to that, we ultimately cannot use this data. In our lab, we were looking at the effects of UV radiation on the development of yeast colonies in a 10 to the negative 5th dilution. On our first plate, our 0-second control plate had a number of 17 surviving colonies, and we believe that our 50% survival point was at 60 seconds. In the second part of our experiment, we replicated, but with SPF 30 acting as a protectant. we did not plate a 0-second control plate, so for survival rate, we had to use our 5-second plate as a 100% survival marker. That plate had 279 starving colonies, and we were unable to estimate a 50% survival mark. Ultimately, we cannot use the data because of our procedural errors. In part 1, our number of yeast colonies surviving did not make sense for the correlating length of exposure to UV radiation. That could have been caused by mislabeling the agar dishes, or we could have incorrectly diluted the yeast. In part 2, we did not plate a control dish, which means that we could not accurately compare our data sets, and ultimately replication would need to happen in order to fix our errors.